Welcome back to Calculus 1, and today we're going to be talking about trig substitution. So this is another type of substitution that utilizes the properties of the Pythagorean identities to find the antiderivative. So a quick refresher, so these are the Pythagorean identities. So sine squared of theta plus cosine squared of theta is equal to 1. 1 plus tan squared of theta is equal to secant squared of theta. And 1 plus cotangent squared of theta is equal to cosecant squared of theta. So as always, I believe examples are the best to start off with. Okay, so for the first example, we have the integral of x divided by the square root of 1 minus x squared. So I already see something that resembles a form of one of these up here. So I'm going to choose strategically for x to be, well, let's see, we have 1 minus cosine squared. So we could do that, and we can let x equal to cosine of theta. Right, then we have to take the derivative of our substitution to put in for our dx. It's going to be negative sine theta d theta. And then if we had bounds here, you would plug the bounds in for x, so you would get theta when we have d theta. So this would be equal to the integral of cosine of theta divided by 1 minus cosine squared of theta times negative sine of theta d theta, because that's going to be our dx. And now we will do the simplification here. So 1 minus cosine squared from our Pythagorean identities is sine squared. And the square root of sine squared is sine. So these will cancel out, and this will become negative 1. And we'll get the negative integral of cosine of theta d theta. The integral of cosine of theta is just sine of theta, so it's going to be negative sine of theta plus c, but we don't know what sine of theta is. So what we will do in that case is we're going to set up a triangle, and this will be our theta, but we know that cosine of theta, which is adjacent over hypotenuse, is x, so it's going to be x and then 1. But we want to find what the opposite is, so we can find opposite over hypotenuse. So it's going to be the square root of 1 minus x squared, and the opposite will be just opposite over hypotenuse will be 1 minus the square root of 1 minus x squared divided by 1. So the sine of theta will be the square root of 1 minus x squared, which will get you negative square root of 1 minus x squared plus c. And that's how it is done. All right, so for the next one, well, I know it can't be this top one because that usually does with the minuses. So we could either choose tangent or cotangent. So let's choose tangent. So we'll make our x equal to 2 tangent of theta. And then we'll take the derivative. It'll be dx is equal to 2 secant squared of theta d theta. Then we'll plug everything in, and we have the integral of the square root of 4 plus 4 tangent squared times 2 secant squared of theta d theta. So this is going to be 2 secant. So this could be 2 secant here, so 2 times secant theta times 2 secant squared of theta d theta. And then we will multiply them together. We get 4 secant cubed of theta d theta. And then later on we'll learn how to evaluate this the integral of secant cubed of theta d theta. So for now, we'll move on. So this integral is the first one that we can do both methods to find. So here I'm going to use tangent because we have a plus. So x is equal to tangent of theta, and dx is equal to secant squared of theta d theta. So this is going to be equal to tangent theta divided by 4 secant squared of theta times secant squared of theta d theta, and we'll divide that, and we'll take the 4 out. So it'll be 1/4 times the integral of tan theta d theta. So we want to figure out what the integral of tangent of theta is. So, well, we can write out tangent of theta as sine of theta over cosine of theta d theta. So as we saw last time, we figured out that we could use the properties of derivatives and antiderivatives to find it using u substitution. So the derivative of sine of theta is cosine of theta. So you could say that u is equal to sine of theta, and du is equal to cosine of theta d theta. So now, this is a perfect example where u substitution would still work, but to flip it, because a d theta is in the numerator. So we have to say u is equal to cosine of theta, and du is going to be equal to negative sine theta d theta, and then this negative sign will move over. So then we will get 1/4 times the integral of negative du over u. And this is going to get us 1/4 times negative ln of the absolute value of u plus c. And now we will just plug everything back in. See, we will get negative 1/4 ln of cosine of theta plus c. So, but we only have tangent of theta, and tangent of theta is opposite over adjacent, but we want adjacent over hypotenuse. So opposite over adjacent will be x and then 1. This will be 1 plus x squared and the square root of all of that. So cosine of theta is going to be the adjacent over the hypotenuse. So it's going to be 1 over the square root of 1 plus x squared, which we can put in for cosine of theta, and it will be negative 1/4 ln of the absolute value of 1 over the square root of 1 plus x squared plus c. And that is the answer. All right, I hope you learned something new today, and I'll see you next week. Bye for now.